Hello and welcome to our 37 in 1 sensor kit series. Today we are discussing about our ninth sensor, that is the linear Hall sensor. In this tutorial we cover the Hall sensor, a sensor to measure magnetic field. So let's start with the introduction. If electric current flows through a conductor, a magnetic field is employed perpendicular to the current direction. This magnetic field exerts a diagonal force on the moving charge carriers, which tend to push them to one side of the conductor because there is a potential difference due to the pushed outwards charge carries a measurable voltage between the two sides of the conductor is produced, the so-called Hall voltage. This effect is called the Hall effect after E.H. Hall, who discovered it in 1879. The effect is depending on the thickness of the conductor, therefore the conductor should be very thin. The linear magnetic Hall sensor reacts in the presence of the magnetic field. It has a built-in potentiometer on the module to adjust the sensitivity of the sensor, and it provides both analog and digital outputs. The digital output acts as an switch that will turn on and off when a magnet is near, similar to the linear magnetic Hall sensor. The analog output can measure the polarity and relative strength of the magnetic field. For the analog input, we have to connect the signal pin from the Hall effect sensor to the analog pin from a microcontroller. The microcontroller reads the analog values. The maximum ADC reference voltage is defined to 5 volt is equal to 1023, which gives us a good resolution because the maximum voltage of the sensor is 6.5 volt. Now I'll show you how you can interface your sensor with the Arduino. Thus, this is all about the linear Hall magnetic sensor. For more updates, just log on to our website www.rapidz360.in and don't forget to share, like and subscribe our YouTube channel.